We will discuss combustion. Very important topic for examination. So, first we will discuss what's the meaning of combustion. Combustion is a chemical reaction and during this reaction large amount of heat and light is generated. This heat and light generate by the ignition of fuel. So first we take example that carbon when react with oxygen and in presence of oxygen carbon ignited into large scale and generate CO2 and large amount of energy which is around 97 kilocalorie. This point is also important that this oxygen comes from air. So we should always put this thing in our mind that this oxygen belongs to air. In the numericals of combustion, we will calculate amount of air required for complete combustion. Before we started numericals, some important points which are very useful during numerical problems. So we will discuss these points. Point number first, amount of oxygen in air 21% by volume. And second point is amount of oxygen in air 23% by weight. And third point, which is also important, amount of nitrogen in air 77% by weight. And next point, amount of nitrogen in air 79% by volume. Number fifth, which is also important, molecular mass of air equal to 28.94 gram per mole. This is the average value of weight, because air is a mixture of different gases, and in case of air there are different gases, so every gas have different molecular mass, so this is the average value. Now, number next, this point comes from mole concept. 1 mole of any gas equal to 22.4 liter at STP. So first we should put in our mind that what is STP? STP means standard temperature pressure. Standard temperature is 0 degree and pressure is 760 mm. These points are very important and we should always remember these points when we solve the numericals. Okay, now we will solve different type of numericals. So first we discuss types of numerical. Types of numericals. In the combustion topic, we will discuss 3 types of numericals and we will cover all the numerics in these 4 types. Type first, numerical, which is related to weight by weight. And second is volume by volume. And third one, volume by weight or vice versa, weight by volume also. And next type is calculation of dry products. So first we discuss that what's the meaning of weight by weight. Weight by weight, it means amount of fuel will be given in gram and kg, and amount of air which is calculated in gram and kg. It means both will be same. So this is called weight by weight. And next, volume by volume. Volume by volume, it means amount of fuel given in meter cube and air will be calculated in meter cube. We already study about meter cube. Meter cube is 1 meter cube is 1000 liter. Volume by weight, it means amount of fuel will be given in meter cube and we will calculate amount of air in gram or kg or vice versa. And next is calculation of dry product. We know that after the complete combustion there is many products. So we will calculate all the products during the numerical. But we will not calculate H2O because here is only calculate dry products. Okay, now we will take example one by one. So first discuss type first, which is weight by weight. So this is the example of weight by weight. A fuel is found to contains carbon equal to 90%, hydrogen equal to 6%, and sulfur equal to 2.5%, and oxygen equal to 1%, and amount of ash equal to 0.5%. Now calculate the amount of air required for the complete combustion of 1 kg fuel. This is our numerical. So in this numerical we are calculating amount of air required for complete combustion, and these are the composition. So first we will draw a table. By this table we will solve this numerical. This is the very important table. In this table here is serial number and then name of compound, and next amount, which is in percentage, and next amount in gram, and next reaction. And we should always remember that this reaction will be balanced reaction. Last is amount of oxygen, which is required for complete combustion, and unit in gram. So this is the table. Here we have 5 values. First is carbon 90%, and second is hydrogen 6%, and third one is sulfur, which is 2.5%, and next is oxygen 1%, and fifth is amount of ash 0.5%. We know that in the given numerical here is 1 kg of fuel. So 90%, it means this is 900 gram and this is 60 gram, and we will convert 2.5 into gram. This will be 25 gram, and 1 gram of oxygen, it means 10 gram of oxygen, and this is 5 gram. Now balance reaction. of combustion. Carbon when react with oxygen, then product is CO2. But this reaction is balanced, so we will not put any value before carbon and oxygen because already this is balanced reaction. Now hydrogen when react with oxygen, product will be H2O. But this is not a balanced reaction, so we will put half amount before oxygen and 2 before hydrogen. Now this is balance. And in case of sulfur, sulfur react with oxygen, then final product with SO2, and reaction is already balanced. And this oxygen will not participate in the combustion reaction because oxygen cannot able to react with oxygen. So this will be used for combustion of carbon, hydrogen and sulfur. So we will not take on here reaction of oxygen. Ash will not participate in combustion. So we have only 3 reactions here. So according to mole concept, here is carbon, so we can say that 12 gram of carbon react with 32 gram of oxygen. So required oxygen will be, because 12 gram of carbon can be able to react with 32 gram of oxygen, and we have 900 gram of carbon, so how many oxygen required? So we can calculate like this, and answer will be 2400 gram. And next, 2 gram of hydrogen, it means 2 element, it means 2 gram react with 16 gram of oxygen. So 60 gram of hydrogen will be react with how much amount of oxygen? So we can calculate this by 16 divided by 2 multiply by 6 multiply by 16, and final answer will be 480 gram. And in case of sulfur, 32 gram of sulfur react with 32 gram of oxygen. So 25 gram of sulfur will be react with how much amount of oxygen? So 32 divided by 32 multiply by 25. Answer is 25 gram. Now total required oxygen. Total required oxygen equal to 2900. We will add all three values and final answer is 2900 grams. We already know that in a given fuel here is 10 gram of oxygen. So this is required amount of oxygen, but this is not a net required oxygen. So if you have already 10 gram of oxygen, then we will subtract this value and net oxygen will be done. This is the net value of oxygen. Now we will calculate amount of air, which is our object. In the above important points, we already know that by weight, oxygen is 23%. So 23 parts of oxygen in 100 parts of air. So if we have 2890 gram of oxygen, then how much amount of air will be involved in this reaction? After solving this, final answer will be 12.56 kg. We will solve these values, then answer will be in gram. We will convert it into kilogram. So final answer is 12.5 kg. So this is the one of example of weight by weight. Now type B. In case of type B, volume by volume. So we will take one of example. Calculate the volume of air required for complete combustion of 1 meter cube of gas having the composition hydrogen equal to 40%, carbon monoxide equal to 20%, and methane equal to 8%, and nitrogen is 60%. So this is our numerical. In this numerical, we will also draw a table which will be used for calculating amount of air. First is serial number, compound, and then amount, percentage, and amount, meter cube, and then reaction, balance reaction, and then required oxygen. Required oxygen. Required oxygen. Unit in So this is our table. Now number 1, hydrogen 40%, carbon monoxide 20%, and methane 8%. So we will convert into meter cube. 40% we know that here in the given numerical total fuel is 1 meter cube. So according to 40% of 1 meter cube, we can write here 0.4 meter cube, 0.2 meter cube of carbon monoxide, and this is the amount of methane. Now we will write balance reaction. Hydrogen react with oxygen and final productive H2O. Now this is balance, and in case of carbon monoxide, this is not balance reaction, so we will put half, and then methane react with oxygen and product is CO2 and H2O. This is not balance reaction, so we will put 2 here and 2 here. Now we will apply mole concept. Here is 1 volume of hydrogen react with half volume of oxygen. Then 0.4 meter cube amount of hydrogen can be able to react with 0.4 multiplied by half. It means final answer will be meter cube. And in this case, half volume of carbon monoxide react with half volume of oxygen, then 0.2 meter cube of carbon monoxide will be react with half amount of oxygen. We can calculate like this. So final answer is meter cube. And in case of methane, here is 1 volume, and 1 volume react with 2 volume. So 0.08 multiplied by 2, and answer is 16 meter cube. So total required oxygen is 0.46 meter cube. We will add all the 3 required oxygens. So total is 0.46. And we already discussed in important points that 21%, it means 21 part of oxygen by volume in 100 parts of air. So if we have 0.46 meter cube of oxygen, then how much amount of air required for complete combustion of this fuel. So if we calculate this value, then final answer will be 2.19 meter cube. And 1 meter cube equal to 1000 liter. So we can also convert this value into liters. 2.19 multiplied by 1000. So final answer is 2190 liter. In next lecture we will discuss